Hey there everyone. In this video, I'm going to solve a non-linear system of equations using Gauss-Jordan elimination. So what I mean by a non-linear system of equations is that I have equations that have a power greater than 1. So these are all power of 2. This should have a power of 2. That's a typo. Okay, so we can solve this using algebraic methods because all the exponents are the same. Now, if they were all different exponents, like 2, this was like the power of 2, then this was power of 3, that was power of 4, something like that, um, then we'd probably have to get into some calculus or something like that. We wouldn't be able to solve it using the skills we learned in Algebra 2. But fortunately, these all are the same exponent. So first thing I want to do is I want to get rid of these two fractions. I don't really like working with fractions that much. Um, Most people I encounter don't seem to like working with fractions that much either. But if I'm going to clear out this fraction, all I need to do is just multiply this equation by 3. And then if I'm going to clear out this fraction, I just need to multiply that equation by 2. Okay, so 3 times 2x squared would make 6x squared. 3 times 1/3 y squared would just make 1y squared. And 3 times negative z squared would make negative 3z squared. And 3 times 1 is 3. So here I did 2 times 1/2 x squared, so that's just going to give me 1x squared. 2 times negative y squared makes negative 2y squared. 2 times 3z squared makes 6z squared. And 2 times 10 makes 20. All right, so now I've cleared out those fractions. And what you want to do here is just replace your variables with a different variable. That sounds kind of strange, but what I mean by that is we're going to let a equal x squared, b equal y squared, and c equal z squared. And so with that, you need to rewrite your system of equations using the letters A, B, and C, and then it will become a linear system of equations. Okay, so you can see here that everything is the same, just I replace all x squareds with a's, all y squareds with b's, and all z squareds with c's. It's at this point I want to begin doing my Gauss-Jordan elimination. So we got a couple options here. I see that we have plane A's on top and bottom and plane B's on the top and the middle equations. So I think I'm going to cancel out my B variable first. So all I'm going to do is I'm going to subtract my row 2 from my row 1. So I'm going to write row 1 minus row 2, and I'm going to create a new row 1. So let's see here. I have a minus 6a, so that's going to give me negative 5a. And then I have b minus b, so that'll go away. And then I have c minus negative 3c, so that's like saying c plus 3c, so that's going to be plus 4c. And then I have 9 minus 3, and that's going to equal 6. And so then I just copied down the rest of my other two equations. And so I need to clear out my b variables from another line. So I could multiply my middle equation here by 2, and then I could just add it to the third equation, and then the b's would go away, right? And so I don't skip any steps. I'm just going to do 2 times row 2 for my first action. Okay, so now I've multiplied row 2 by 2. 2 times 6a, 12a. 2 times b, 2b. 2 times negative 3c, negative 6c. 2 times 3 is 6. And so what we actually have here is I am canceling out, I didn't notice it before, but I'm going to be able to cancel out my C's and my B's. So I'm going to do row 2 plus row 3 here. And so doing that, I'll get 12a plus a, and that's going to make 13a. That'll cancel, and then I have 6 plus 20, that's 26. Okay, so here we have our three equations now. I have 13a equals 26, so I might as well just solve that for a. If I just divide both sides by 13, I'll get 2, right? So to show my work, divide 13, a equals 2. Now that I know that a equals 2, I should just plug it in to that top equation, and since there was no b variable, I only have two variables, and now that I know one of the two, the only thing that will be missing is the c. I think I'm over explaining it there, but so I'm going to do negative 5 times 2 plus 4c equals 6. And so negative 5 times 2, that's going to make negative 10. So we have negative 10 plus 4c equals 6. I know I can add 10 to the other side, and I'll get 16. So I have 4c equal to 16. So I'll divide both sides by 4, and I'll get c equals 4. And so now that I've gotten my C and my A, I'm going to take A is 2, plug it into that third one. Then I'll take my C is 4 and plug it in to the third one as well and solve for B. So plugging in A is 2, it's going to say 2 minus 2 times B, and we don't know what B is yet, plus 6C, so plus 6 times 4 equals 20. So I know that 6 times 4 is going to make 24, and so I have 2 minus 2b plus 24 equals 20. And so combine your like terms of 2 and 24, and you're going to get negative 2b plus 26 equals 20. And so we could subtract 26 to both sides, and I'm going to get negative 2b equals negative 6, and I'll divide both sides by negative 2, and then I will get b equals positive 3. And so at this point, in a typical problem, you'd be like, okay, my ordered triple is 2 comma 3 comma 4. However, we said early on that let a equals x squared, b equals y squared, c equals z squared. So you are going to set 2 equal to x squared, and then we're going to set, what was b again? 3. 3 equals to y squared, and then c was 4, so 4 equals z squared, and then all you got to do is solve for x, y, and z by taking the square root. All right, so if 2 equals x squared, then the square root will be my answer for each of these. Now here's the important thing for square roots. Whenever you take the square root, a plus or minus sign. That's because if you think about it, when you multiply two positive numbers together, you get a positive number, of course. But when you multiply two negative numbers together, you still get a positive number. So if I did 2 times 2, I'd get 4. If I did negative 2 times negative 2, I'd also get 4. So anytime you take a square root of a number, make sure you include the plus or minus sign along with your solution. So these numbers would make up my ordered triples. And so I say ordered triples because technically what you're supposed to do is you're supposed to uh, write multiple ordered triples going through all the combinations you can make. So for example, if x equals the positive square root of 2, there could be a solution with a positive square root of 3 and then a positive 2 for z. There's also a possibility of getting like a negative square root of 2 with the positive square root of 3 and the positive 2 for my z. And we're going to get something like 8 different combinations here, or permutations. I get those kind of mixed up. But you could go through it and you could say, well, if I had the square root of 2 come first, I could also have a negative square root 3 come second, and then a positive 2. I could have a square root of 2 and a negative square root 3 and a negative 2. I could have a positive square root of 2 and I could have a positive square root of 3, but a negative 2. I could have, I think that's all the positive ones. So let's see here, we'll do negative square root of 2, negative square root 3, and positive 2. And then I could also do a negative square root of 2, positive square root of 3, negative 2, and then I think I have one more where they're all negative. Negative square root of 2, negative square root of 3, and negative 2. And I think that is all the different arrangements we could make. If I missed one, feel free to put it in the comments, but I think ultimately I've made my point. So yeah, a little bit of extra work whenever solving these nonlinear systems of equation, but yeah. Other than that, thank you for watching this video. I hope you learned something, and goodbye.